Howdy! Now we're going to talk about electric potential. So we're going forces. Electric fields are force per unit charge, and then electric potential is energy per unit charge. Or now I'm going to use U over Q. That is the basic definitions of these three. So V is defined as U divided by Q. That's what the three little lines mean. It means that it's defined as. And so the units of this are going to be the volt. And 1 volt is equal to 1 joule per coulomb. This is measured in volts. And it's often referred to in a couple of different ways as potential, voltage, or potential difference. You can effectively say that these two are the same. So these two are equal. Potential and potential difference will have slightly different meanings. Mainly, we are always going to be concerned with the potential difference, which is the difference in potential between two different spots. Like returning to my mountain, there's a difference in the potential energy between this spot and this spot. One just has more potential energy than the other. And so there will also be a potential difference between those two spots. Since potential is energy per charge, we can develop an expression just sort of in an ad hoc way. Here we have to use calculus to do it correctly. But potential is U divided by Q. And I know that U is KQQ over D divided by Q. So if I just look at it from a dimensional point, these Q's would cancel out, and it would leave me with KQ over D. And so this is the expression for potential. If Q is positive, the potential is positive, and vice versa. If Q is negative, then I'm going to have a negative potential. If D is large, V is small. If Q is big, what is V going to be? V will also be big, because I have an inverse relationship between V and Q. I have a direct relationship between V and Q, and an inverse relationship between V and D. Overall, we're going to be interested in the potential difference. Which is the difference in the potential of two different locations. So a charge at this point might have a potential of 10 volts, and a charge over at this point might experience a potential of, say, 12 volts. The difference in these two, delta V I'm going to call it, will equal to 2 volts, just 12 minus 10. If a particle moves from point 1 to point 2, how do we express that potential difference? Let's say that I have 4 volts here and 2 volts here. This is my initial place. This is my final place. So if I'm moving from 4 to 2 volts, from 1 to 2, my delta V will be VF minus VI. VF is equal to 2 volts minus 4 volts. That's equal to minus 2 volts. Batteries are labeled according to their potential difference. That's going to be the difference in potential between their two terminals.